So my name's Kerry Dalton. I'll just introduce myself first of all and say I prefer not to have a stage because this is quite practical and quite hands-on. My name is Kerry Dalton. My company, if you like, is called Make Maths Count. I came over from the UK to Dubai in August last year, where I am deputy head at King's School Al Barsha. In the UK, I was head teacher in my own primary school for 6 years. Before that, I've taught in every year group, from early years up to secondary. My small village primary school, as you can see in the middle there, is very different to the 1,950 children that we have at Barsha at the moment. I've worked with Maths Hubs for Yorkshire Riding Maths Hub, where I developed CPD packages for teachers. I worked on the EEF project, delivering training for classroom support assistants. And I also was Maths lead and CPD lead for my Teaching School Alliance, which was North Star, based in North Yorkshire, an alliance of around 60 schools. So hopefully some experience and some ideas to share from the UK over here in Dubai. What brought me here is last Easter, I came over and delivered some workshops, maths through stories, hands-on maths, practical approaches like we're about to do, and I loved it so much I decided to stay. So I went home and then very quickly bought another ticket back to Dubai with my family, and this is where we live now. So it's a complete pleasure to be here with you this afternoon. If you already joined me for my session this morning, it is the same. So I won't be offended if you think, oh, I thought it was something different. But this is all about developing the use of manipulatives to deepen understanding for children. Is that what you thought you were here for? That's good. Okay, so aims are to explore practical hands-on approaches from early years up to year 6. I do lots of this. I do lots of, now it's your turn, lots of very practical. So hopefully there's something that you can take away and implement tomorrow. I would normally say today, but I don't think anybody's going back to school today. And we're going to think about how we can deepen our understanding, working towards mastery level understanding, with about 10 minutes a day of structured activities. So before I start, I really should point out that if you Google Kerry Dalton in the search for anything that I share with you, there is somebody in South America called Kerry Dalton who's currently awaiting some quite severe punishment for mass murder. That's not me. So in case you think, how did that lady get out of prison? That's not me. So to find any of the materials for today, I'm not even kidding, it's in the top 10 Google searches. If you ever Google yourself, that's what happens. So the first thing I'm going to show you is, I'm really not here to sell anything. I did happen last year to write some books about the use of manipulatives, hands-on resources from year 1 to year 6. These are those, available to buy on Amazon. But I don't get any commission, so really, I'm not too bothered if you do or you don't buy them. This is the most important one to share. It's called Making Maths Count. It's a free PDF that you can download, and I started it last year as a teaching challenge. So I really, really love teaching maths. I was never the best mathematician in the class at school myself. In fact, I was that child who sat at the back saying, but I don't understand why. And so now I kind of build that into my own teaching and always aim to explain the why to children. So I've always got lots of ideas about using everyday objects, using maths equipment, formal maths equipment, but not all teachers feel the same about teaching maths. So in the Teaching School Alliance, they were saying, yeah, but Kerry, you're not in our school, or, where'd you get the ideas from? So I said, look, I'll throw some ideas down on paper, and this was them. So the aim was that if you could have a go at using everyday objects for 6 weeks, 10 minutes a day, aside from your maths lesson, children's understanding would be greater. It covers all the maths objectives, some for 1 or 2 days, some over a week, but the national curriculum objective is in there, and then there's a really easy to follow, I think, I'm told, example of what the activity is with a photograph. And the idea was that a teacher could deliver it, but also an LA or a TA could also deliver the sessions. From there, it seemed to be quite well received, so I wrote the books, but it's the same idea. 10 minutes of practical hands-on maths every single day. Right, so that's what I'm all about. Let's have a go at some of the activities. I've explained about the Make Maths Count. My first question to you, though, would be, what makes a good reader? If you just shout out some things. What makes a really good reader in school? Practice, yeah. Read every day, probably. Probably that child who falls asleep with a book on their face because, you know, it's nice and relaxing and they enjoy it. Yeah? What else? Good reader. Yeah, enjoy reading. Probably go down the library if there is one. Probably not so much in Dubai. What about a good writer? You probably are somebody that reads. They're probably quite good at spelling. They know their sentence structure. They probably do read quite widely and they feed those ideas into their writing. What about a good scientist? Curiosity, absolutely. Anything else? Inquisitive, kind of don't give up. What about in a science experiment? You think it's going to go one way and it goes the other way. You just have a go. You try and figure out what went wrong and then you find your own way, you explore different pathways, but you don't give up. Nobody mentioned any Year 6 spelling, punctuation and grammar objectives. Nobody mentioned knowing the periodic table in science, but what we've described are attributes of children that are good in that subject area. And it's exactly the same in maths. So I challenge you on your tables just to chat to the person next to you. What makes a good mathematician? Over to you just for a minute. What makes a good mathematician? Talk to the person next to you. It's things like talking about maths, being interested and inquisitive, not giving up at the first hurdle, showing you're working out. For me, I always say, sometimes I'll give children the answer to make them show me how they got there. You know, here's a problem, just to let you know, this is the answer. What I want you to do now is show me you're working out, because that, for me as a teacher, is the most important part. Seeing what children know and what they understand. Because if there's a misconception there to unpick, then that's how you're going to find out what it is that they know, by asking them lots of questions. So being good at maths isn't necessarily being the best, computational expert. Sure, you're going to need that skill set of times tables, number bonds, instant recall facts, but really it's those deep-rooted skills and attributes that children have that are important. I've worked a lot with the maths hubs and observed teachers from Shanghai when we had the Shanghai Maths Project in place. I've been really, really lucky to work with a vast range of schools across a number of maths hubs in the UK. They're groups funded by the government to develop children's interest and engagement in mathematics. And the big thing that really came out of that, and all the work, anybody use White Rose Maths as they're planning? Yeah. So White Rose Maths, it's all kind of based on that concrete, pictorial, abstract approach, which I'm really going to share with you today. Concrete being the hands-on practical, so things that are, objects. Pictorial being the iconic stage of understanding and development, and things like number lines, drawings, bar models, they're pictorial representations. Move it before we can even think about moving into the abstract. And quite often where understanding sort of falls down, I think, is because we miss out one of these crucial first two stages. Children have to go through that process. If they haven't touched it and felt it, they don't really understand it. So they can't move into the pictorial representation. And actually, by the time we just kind of launch in with abstract, then they're lost. They haven't got anything to call on. They haven't got models and images in their minds. So for me, the first two stages are the ones that I want you to kind of go home and feel passionately about, like I do. So teaching is most effective when? I have to fully credit Mike Askew because I was at a conference of his about 10 years ago and I still agree with all that he said. He said that teaching is most effective, looks like the clicker's started to work, when it builds on prior knowledge, which we know, spiral curriculum, when it exposes and discusses misconceptions, doesn't avoid them, doesn't hope that children don't have them, but actually tackles that head on. Uses higher order questioning, again, I don't think that's any surprise to anybody. Makes appropriate use of that whole class input, and then small group work. It's about reasoning, not getting the answer. and it's about those rich collaborative tasks. If anybody already doesn't use Enrich at least once a week in their teaching, please do. Totally free website, lots of really, really good challenges for children, collaborative and independent tasks. It asks, good teaching is about using technology to enhance understanding, and for me, that developing mathematical language. Particularly here in Dubai, we had our International Day last week at school, and we had 83 nationalities at King's School Al Barsha. 83, that's amazing. But what that made me realise is potentially 83 languages, plus the language of maths, plus English, plus Arabic. There's so much that, you know, comes to children, and particularly in a maths lesson. So again, a resource to share with you now is the mathematics the mathematical vocabulary booklet from about 10 years ago with the numeracy strategy. If you give one thing to your teachers in school or share, it's that. Again, free to download, Google mathematical vocabulary. All the words in year group order that children will need are in there. I can't emphasize enough the importance of a quick pre-teach. LA, outside of the classroom, before the maths lesson, quickly go through the vocabulary for today, things like that. So we have, the use of it's called Mathematical Vocabulary. It was produced by the Department for Education about 10 years ago in the UK, but things come back in fashion. So, again, it's a PDF that you can just download. It's from reception up to year 6, according to the concept, so, you know, place value vocabulary, counting vocabulary, addition vocabulary, etc., all the way through from reception to year 6. And it also, good teaching recognises what's been learnt and how we learn it. Right, with all that said, let's get cracking on with some activities. Your first one is to do with counting, because counting for me is the thing that you'll never ever do too much of in your classrooms. Whether you're an early years teacher or a year 8 teacher, counting in decimals, counting in fractions, counting in whole numbers, counting in equal steps of, counting from any given number are all crucial for learning the 4 calculation strands that we need children to be proficient in. So, I'm going to ask you to work with somebody nearby, and you're going to need 100 square, which you should have in front of you, and no more than 20 objects. If in a pair, you can have 100 square and count out 20 objects, be they ladybirds, jungle animals, pegs, beads, button counters, my little snails. 20 objects, please. This kind of activity is probably suitable for FS2, but also for any child new to English. English is a second language, or just, you know, needs that fluency in mathematics. So one person is going to point to a number between 1 and 20. And the reason I've given you 100 square, I know that children in reception don't need to count to 100, but it's to expose them to this is where it fits in the big picture. And also just kind of give them that insight into this is a piece of mathematical equipment that can help you. It's really great. So give them the 100 square. You're just going to focus on those top 2 rows. Partner 1 and partner 2 are needed in each pair. So very quickly decide who's partner 1. Put your hands up. Partner 2. Partner 1. Partner 2. Still not decided. This table over here. So partner 1 will point to a number between 1 and 20, and partner 2 will count out that number of objects and show partner 1 how you count out, because this is about one-to-one correspondence. Okay, so play along with me and pretend you're in reception. Okay, so partner 1 do that, partner 2 do the counting. Okay. You did it, well done. You can have 2 house points. Okay, so how it should look when you're counting and you've got that really clear one-to-one correspondence is you move one object at a time. And we can't assume that children know how to count. Okay, I often assume that children know how to count, and I do things at home with my own children like that, well, when they were growing up, teenage children now. But, you know, somebody has to teach children how to count, and it's one object at a time. How often do you see children go, here's a pile of objects, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's not 9 there, there's 6. Oh, I'll count them again. 1, 2, 3. Oh, I've got 4 this time. Well, you can't have, because the number of objects hasn't changed, and we still haven't got it right. So children need to be taught that one-to-one correspondence. And as I say, it doesn't come naturally, and we need to teach them how to check their answers, which is, again, another part of the mathematics. How can they go back and check their own work? Okay, the next thing I want to talk to you about is subitizing. Do you all know what subitizing is? Yeah. So subitizing, if you don't know, is counting without counting, which sounds a bit bonkers to me. So how we're going to do this, again in your pairs, is one person needs a paper cup, and the other person can keep those 20 objects handy. And we're going to see how many objects you can count without counting, and how it looks is, show no more than 10, because I don't think you can count, you can't subitize more than 10. So you might be able to. This gentleman here's going, actually I can. So we'll see how far can we count without counting. So show an arrangement of objects, probably move away from the 100 square so you've got a nice clean background. Cover them up with a cup, and then ask your partner to tell you how many objects there are there, but only show it for half a second, okay? And then I'm going to ask you how you counted them. Off you go. Okay, that's a really good point, I think, to interject. What strategies did you use to count without counting? This lady here, sorry, what's your name? Kate just suggested, she said, oh, I was really kind to you because I laid them all out nicely, which is true. You have a look for a pattern, don't you? You try and spot a pattern. How else did you count without counting? Maybe the arrangement? Sorry? Yeah? Yeah, group them, partition them maybe, think, oh, 3 and 4, so that's 7 there, yeah? How far could you get? You could all count 1 without counting, yeah? 2, 3, 4, 5, 6, 7. Have a go at 7, 8, or 9. Show your partner, see which is the highest you can get to. Okay, how many do you think we can get to? 7? 8? Somebody said 13? Wow! 13. It's amazing. Usually around 6, which I'm told from one of the speakers this morning is because animals subitize. When birds have a nest of eggs, they know when there's 4 there, and they know when one's missing. But when there's many, they don't. That's why we have a tally. 1, 2, 3, 4, 5. We need something different for 5, because 5 and 6 is when it gets quite tricky. And if you think about a dice or dominoes, we have that set pattern. If you have dot, 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 we know that that's 4. We recognize dot, dot, dot as 3. So exposing children to lots of dice games and those opportunities to count is good, because it creates those pictures for them in their minds. Okay, the next game we're going to play is a place value game, and it's called First to 50. Do any of you use it already? Ooh, fantastic, yeah. So First to 50 is about exchange, and the concept that 10 of one thing needs to be exchanged for 1 of something else. Because when we count, and our decimal system is based on tens, so we need to make sure that children understand what exchange is all about, because we need it for addition and subtraction, for every calculation, in fact. And it's really important that children don't think of it as borrowing or carrying, and they understand what that process is. So each pair needs 1 foam, not noisy dice, and you need 5 matchsticks and 10 objects each. 5 matchsticks, 1 dice, and 10 objects each. So I have 10 cubes, and Melanie has 10. And I have 5 matchsticks, and Melanie has 5 too. So I'm going to roll my dice, and I roll a 6. Oh, yes, fantastic. So I count 6 cubes out. Melanie, it's your turn. Oh, Melanie rolled a 4, so I'm thinking, yes, I'm ahead of the game here. I'm going to roll the dice again. 2. So I move my 2 to join the other 6. And Melanie's rolled a 5. She's got 1 cube left. I've got 2 cubes left. Ready? I've rolled a 5, and I only have 2 cubes left. What can I do? I'm going to put the 2 with the 8 cubes and swap those for a matchstick. And I actually need 3 more cubes. So what I've got now is my cubes back in the middle. I've got 1 matchstick and 3 cubes. So that's a total of 13. And now it's Melanie's turn. Ooh, she's rolled a 5. She's ahead of me now because she's currently got 14 in her total. It's the first person to exchange and exchange and exchange until you've got your 5 matchsticks. Does that make sense? So have a practice at that in your pairs. And when you've won, if you just, I don't know, dance, sing, or just humbly say, I won. I don't mind how you do it, but just have a go at first to 50, rolling the dice, taking it in turns. The game first to 50 can be first to 20, it can be first to 30, but it can also be first from 50. So we quite often use it as a way for embedding that understanding around what exchange is. You need to subtract, you've rolled a 6, but you've only got 4 cubes there. What can you do? You exchange a matchstick or a lolly stick or a peg or whatever you have for 10 objects. And the important thing here, I think anyway, you may or may not agree, is around not using mathematical equipment. Because I don't want there to ever be a reason that you can't do something like this. This is about embedding place value understanding and the exchange process rather than having 25 sets of Dean's equipment in your classroom, because we don't have that at my school. We don't have enough. So it's about finding ways around that to still get to the same end goal. So that's first to 50 or first from 50. We're going to have a go at some rounding activities now. So we've used some counters, some pegs, so 100 square. I'm going to ask you to grab a counting stick, please. So one of the plastic yellow counting sticks. These are individual counting sticks. I'm going to tell you something about me too and give you an idea of what I'm like as a person. I moved to Dubai in August. I brought 14 boxes of personal belongings from home, and 11 of them contained maths equipment. How sad am I? But that's me. So these were they. So these are individual counting sticks, a bit like the ones that the teacher uses at the front of the classroom. Again, if you don't have these, don't worry. I would just create them in a Word document. I'll happily, in fact, I have put some on my blog if you want to have a look, where you can just download it. 10 alternate coloured cubes, or make them out of Unifix cubes. So what you're going to do is, now this is a Year 6 activity. The objective is rounding any whole number to a required degree of accuracy. So one end of your counting stick is going to represent 10,100. The other end of the counting stick represents 10,200. What's each interval worth? You might need to make a note of the numbers. 10,100, 10,200 at the other end. What's each interval worth? 10. Perfect. So what I'd like you to do is place a matchstick, please, on the number 10,143. Oh, sorry, use the yellow and blue, the 10 yellow and blue sections. That's the one, yeah. 10,143. Show a partner, see if they agree. Yeah? And then now have a go with each other. Give each other a number. You can choose a different start and end number if you like, or stick with the ones I've given you. Okay, the idea is that for children, when you try and explain what rounding is, and we've all taught the rhyme, 1, 2, 3, 4, round down to the one before. 5, 6, 7, 8, 9, round up to the next one on the number line. But we don't say why. So you end up trying to explain a rule, which is, well, if it's 5, 6, 7, 8, or 9, you go that way. Well, don't worry about it, because if it's over that line, then you can also go that way. Well, actually, you need to look at the second decimal place in. And you end up, have we all been there, tying yourself in a knot, trying to explain this concept. Now, I'm not suggesting I've given you anything there that, that's going to sort of blow your mind with science, but just that really simple image for children of, oh, I see. That's actually physically closer to that end of the number line, and that, that 10, 100,000, 10th, 100th, whatever it might be, and that end represents that number. They can see why we're rounding up or rounding down. It gives them an image to hang their understanding on. And the beauty of that is that you can use it with any number. That was a Year 6 objective, but you could equally use it with rounding to 10 or rounding to 100. But it explains the why. Okay, we're going to have a go at some, what else shall we have a go at? It's 10 to, this session finishes, I think. So we're going to have a go at some fractions. Could I ask that, in fact, I think if I just show you here. So, my tower here, how many cubes in my tower? 4. That's one whole tower. What does each cube represent as a fraction? 1/4. So bear that in mind. That's my one tower with 4 cubes in it. That's another tower with 4 cubes in it. And, sorry, microphone interference. Here's another tower with 4 cubes in it. Okay, if you have that as your image of what a whole one looks like, and then we say, okay, well, 3/4 times 3. We can give children, that's what 4/4 looks like. 3/4 times 3 looks like this. What do we need to do to calculate our answer? We need to put them into whole towers, don't we? So 3/4 times 3 as a picture looks like this. And I could actually draw that myself with squared paper, but giving children a model to hang their understanding on and actually see what's going on there. It's not about times the top by the bottom. There's no magic involved. It's just teach them, what's happening with the numbers. They're really simple. Cubes are amazing. They're my favorite maths resource because you can use them for so many things. I wanted to, one other activity. With your counters, we're going to have a go at representing numbers. Each take 5 counters. Counters, objects, cubes, matchsticks, whatever you like. And now, without taking any from anywhere else or anybody else, show me 6. Oh, you can't use thumbs? What could you do? You've still only got 5 counters. What can you do to show me 6? Sorry? You could, yeah, you could do. You could. What about if one object was had a different value, a different unitary value? So instead of being worth 1 now, say if they were worth 2. If each object was worth 2, see if you can show me 6. You're probably holding up 3 counters or objects now, aren't you? Okay, see if you can show me 1.2 using your 5 counters. What unitary value are you going to give each object? .4, you could give it 0.3. But just by changing what each object's value, we can actually represent numbers in lots of different ways. And again, for children, this is really important, because if we tell them that the only way to partition a number is into 10s and 1s, that's not right. 349 could be 300s, 4 10s, and 9 1s, but it could also be 200s, 14 10s, and 9 1s. And in always going with the hundreds, 10s, 1s in the first example, we're teaching children that actually numbers can't be ever changed into anything else. But when we come to division and subtraction, we need to have that confidence to manipulate numbers to what we need them to be. and get children experimenting and playing with number. So I hope I've given you some examples of ways that you can use everyday objects. Sure, the counting stick was an official maths piece of equipment, but it could have quite easily been a laminated piece of paper or some squares in the maths book. Hopefully I've given you some ideas that you could take away and some examples of how models, images, and the use of manipulatives can help children develop their understanding, because that's what I said that I would try and do. If you like the ideas, then please do download that free, don't forget to Google Making Maths Count, Kerry Dalton, not just Kerry Dalton. Then you can download that free booklet, which is 10 minutes a day of everyday objects to deepen understanding. If you are interested, I run a UAE Maths Challenge, which is trying to develop some of those social studies aspects to maths. All sorts of different examples that I've used. If you just hashtag UAE Maths Challenge, you'll see lots of examples for Key Stage 1 and 2. Tweet your pictures of maths in action. Don't forget to include me, which is @MakeMathsCount. Try our ideas tomorrow, and if you want to use any of those resources that I've mentioned today, then have a look at my blog. You'll see them on there, along with lots of other ideas for CPD. I hope that's been useful. I've really enjoyed it. Thank you very much.